Yep.
We're not doing it today, or?
Nope, we won't do that. Okay, so here we go. When we first started teaching this class, we had more days. Right now, we again only have 39 during second quarter, and instead of having 50 minutes of class period, we have 45. And so teachers have to make adjustments. So every once in a while, you get rid of something, which is we'll get rid of those word problem pieces for today, and we won't go back to those. But so today we want to talk about what is considered function operations. And to just try to give you a frame of mind and to help you see that there's many things that you don't know about this yet. The fact is that there's kind of two things. There's what we call groups, and you don't have to write this down, and there are what we call operations. And so if I say operations, you think of addition, subtraction, multiplication, division. What are some other operations that you're aware of in mathematics?
Chicken dance or just a letter lock?
Just get here.
Yeah, no, I went to jail.
Oh, you did. Oh. Are you okay? Good. No worries. Some people. Who? Oh, that's right. But you guys, didn't you guys have to go? Oh, yeah. Hi there. That's right. You guys didn't have to go to the auditorium. You're coming from the class field trip thing, right? Oh, you did?
No, I didn't.
Okay, that's still funny, though. Okay. So what are some other operations that we have in mathematics? Yep, okay, so squared, square root, cubing, things like that. So how about something else? That's more like dividing. Absolute value is an operation. If you take the sign of something, that's an operation. And the fact is, you could take, say, a logarithm of something. There's all sorts of operations that exist. Shh, okay? Now, would you agree that we tend to think about addition and subtraction, multiplication, division most often? And if you notice, we as human beings are wired to where we like addition and multiplication a heck of a lot more than we like subtraction and division, don't we? And it's also true that some operations, they hold different properties than others. For example, 3 plus 5 is equal to 5 plus 3, isn't it? That's called the commutative property. But is 3 minus 5 equal to 5 minus 3? No, so not all operations hold the same properties. There's a course in college called Abstract Algebra where you see all of those. But there's groups that you work with, and so far the groups that you work with are numbers. Like all real numbers. That's really all you work with. Whereas there's other things. You're like, well, what else could you work with? Well, you could actually work with things that we call matrices. You guys do a little bit of matrices ever? That's a different group of things. And actually, there's another group. There's a group called functions. And you're familiar with functions, right? And later on, okay, we're going to teach you next week 2 new operations. They will be something called composition and inverse, things that you do not know yet. And they're not that difficult, but we're going to teach you that. Today, we're going to focus on addition, subtraction, multiplication, division. Nice and easy. You ready? And f plus g of x is defined as f of x plus g of x. Now you're wondering what that means, and so let's go straight to an example. It says if this is f of x and this is g of x, find f plus, f minus, f times, and f divided by g and their domains. So what we're going to do is we're going to do f plus g. So instead of having 2 separate functions, we're going to put them together. And all we have to do is just add them. And in this case, we have x squared and we have plus x minus 1. That's it. Now, they can get more difficult if we deal with, say, radicals and fractions and things like that. But everybody okay there? It also works that if you have subtraction, it's f of x minus g of x. And if you have multiplication, it's f of x times g of x. And if you have division, it's f of x divided by g of x. Exactly like you would think. Now, the fact is that really as you come to this part, I'm not so concerned about your ability to add, subtract, multiply, or divide these things. I'm more concerned about your ability to identify the domain. So we'll first do this and then we'll talk a little bit more heavily about the domain. If I do f minus g of x, then I subtract those two. What's going to happen if I subtract those two? X squared minus x plus 1, because you have to distribute the negative sign. Everybody agreed? Distribute your subtraction sign so that minus is going to change to a plus. I have f times g of x. So I take x squared times x minus 1. What are you going to get? X cubed minus x squared. Good. These are all things we've practiced before, agreed? And then we have f divided by g of x, and you will get x squared over x minus 1. Can I simplify that in any way? Could I cross off the x's? No, definitely not. So let's just leave it alone and call it good. Everybody okay there? Awesome. So what's really important is to identify domain. Now, just a show of hands if domain was at least a little bit of an issue for you on the last test. Like you're like a little bit confused about domain. Okay? Yep, see some hands going up. Domain was tough. Here's your chance to revisit it and get it right on this test. Okay? So, if you remember, we had domain really fell into one of three categories. If it was a polynomial, the domain was all real numbers, right? If you had a square root, you would have to say that you can't take a square root of a negative, right? And if you have a fraction, you would say you can't divide by 0. So those are the types of things that we're going to think about. When you add functions together, the domain actually ends up being the domain of f intersect the domain of g. And I know that that looks weird, but we're going to make complete sense of it here in just a second. So, for example, okay, Miss Hannah kind of had that crazy look on her face. Let's help her with that crazy look. F of x is x squared. That's a parabola, right? What's the domain of a parabola? All real numbers. And then we have x minus 1. That's a line, right? Shifted down 1. What's the domain? All real numbers. And what's the overlap between all real numbers and all real numbers? All real numbers. So that means that the domain of this one will also be all real numbers. You see that? So it's the domain of those two overlaps. So I'm going to put domain here, and it's all real numbers. Now that's what it is for addition. But for subtraction, it happens to be exactly the same. And for multiplication, it happens to be exactly the same. And for division, it happens to be exactly the same. Except g of x cannot be what? 0, because you can't divide by 0. So that's the only thing that we have to change. So the domain of this one is all real numbers. The domain of this one is all real numbers. The domain of this one is all real numbers. Those three will always be the same. You good with me? So the domain of this one on the bottom is also all real numbers, except we have to exclude wherever the denominator will be equal to 0. Uno. So therefore, x cannot be 1. Not too bad? Okay, so that's the most basic example. Today we're going to get through letter B, but we'll have to do letter C tomorrow. Okay? So let's move on to letter B. What makes letter B different? Yeah, we got these root things. So we'll review like what we can and can't do with root functions. So we're going to do f plus g of x. And can you tell me, like, if I add these two together, can I take the 2 plus the negative 9 and get a negative 7? Like, can I add these things on the inside? You can't, can you? Like radicals, you can't add the piece underneath unless they're exactly the same, right? Like, for example, if you have 2 square roots of 7 plus 3 square roots of 10, that does not give you 5 square roots of 17, does it? No, you would have to have the radicands be the same, and those are not the same. So all you can do is raise the square root of 2 minus x plus the square root of x squared minus 9. That's it. Can't do anything else with it. Sir?
Let's say they were to square the split of 1 in for the for example. Does that change it?
Suppose you have square root of 1 plus square root of 3?
Yeah.
Can't add them. Those two have to be the same. If you had, say, 5 square roots of 3 plus 4 square roots of 3, now that makes 9 square roots of 3. Those have to be the same. In this situation, they are not. So how about subtracting? Can I just go ahead and subtract them?
No.
So I got square root of 2 minus x, and it'll be a minus the square root of x squared minus 9. You may not subtract radicals unless the radicand is the same. So for functions, we really can't do much with those. Are you allowed to take what's underneath the radical and multiply them together?
Yes.
Yeah, you are. If you have the square root of 3 times the square root of 2, that's the square root of 6. You can take those two things and multiply them together and make one radical. So if we have f times g of x, the fact is that we can multiply these two together. So let's multiply them, okay? So I got 2 times x squared, I'll have 2x squared. What after that? Yep, so I'll get a minus 18 minus x cubed plus 9x. See how that all fits now underneath one radical? Okay, so that's our new function. Are we okay with that? I do want you to multiply that out so you understand that you can do that with two radical functions. We all good? All right, are you allowed to divide them? Yeah, just like you can multiply them, you can divide them. So f divided by g of x, and all that means is we can take and write it under one division sign. So it's 2 minus x over x squared minus 9. So again, I want to see one division sign or one radical so that you understand you can put them both together. We okay there? All right, so let's talk about the domain. And here's where we need to lean in a little bit because we didn't always do just a great job with domain on the last test. And that's normal. You guys are at a pretty normal spot for how students have done it. A lot of people get it better the second time. So, true or false, the domain of this is all real numbers. False, because I know that I can't take the square root of a. So I'm going to say 2 minus x must be greater than or equal to 0. And I'm sorry, you don't have a lot of space to kind of write this down, but it's going to take me a little space to be able to write this domain. Okay? So I got 2 minus x is greater or equal to 0, so I subtract the 2. I get negative x is greater or equal to negative 2. X less than or equal to positive 2. Right. Are we okay with that? So that's the domain of f. Everybody could do that one, right? Now the next one's a little bit more difficult, isn't it? If we say that x squared minus 9 has to be greater than or equal to 0, notice there's something that needs to go off in your brain saying, oh, I've got an inequality and I have something that's not to the first power. That means you got to make a graph or a table, okay? So I factor this, I get x minus 3 times x plus 3 has to be greater than or equal to 0. So in order to answer that question, I'm going to look at the graph because I know what the graph looks like. What does it look like? It's a parabola, right side up or upside down. It's a right side up parabola. So I'm going to draw that guy right here. And I'm going to label the positive portion and the negative portion and the positive portion. So where is it greater than or equal to 0? What is my result? Is everybody okay with that? So it looks like we have one domain right here, and we have a second domain right here. And what the notes told me is that the overall domain is the overlap of those two. So in order to see the overlap of those two things, as I'm teaching this, I'm going to actually put it on a little graph here so you can see it. I'm going to plot the number negative 3, 2, and positive 3. Now, for this one right here, I have x is less than or equal to 2. And for the other one, I'm going from negative infinity to negative 3, union 3 to infinity. Close, but not quite. Let's think about it this way. Not quite. Are both the graphs here? No. Are both the graphs here? No. Are they both here? No, you only have the blue one right here, right? Are both of them here? Yes. So because they're both here, you can see it's from negative infinity to negative 3. You see that? I picked the 2 because of this one. See that now? So that one came from here, and then the other part came from here. So I look for the overlap of the red and the blue, and this is the only spot where they overlap. That's the intersection. So therefore, that's my domain. So as I list my domain, I go negative infinity to negative 3. As I figure it out for the addition, it's the same thing for subtraction. I don't need to change anything at all. And I don't need to change anything for multiplication either. But I do have to change it for division, don't I? I have to think about what number would you plug in the bottom to make 0? 3, but 3 is not part of this, is it? What other number would you plug in to make 0? Negative 3. So I don't want to include negative 3. So how do I do that? Put the parenthesis on that one. And that's my domain. What's that? So here we're including the negative 3 because of our graph. It says negative 3 is included with both the blue and the red. But for division, if you were to plug in negative 3 here, you would get negative 3 squared is 9, minus 9 is 0. And you can't have 0 in the denominator. So therefore, we have to not include the negative 3.
I was like, I put a high circle or whatever.
Doesn't necessarily have to do with an open or closed circle. Your closed circle makes it included. Yep, yep. Okay.